Aloha everybody, this is Gigi from Kauai Community College. In this video, we will be talking about quadratics and those that are like a quadratic. Okay, so here we go. Suppose you have 2 times x plus 7 squared minus 5 equals 11. That's an onion problem. We've seen onion problems before, but I want to call out this problem again, just so that we can review, because it is setting up the stage for the next few problems that we're going to be dealing with. All right, so add 5 to both sides, peeling layers, divided by 2, and then to undo square, we'll have to square root both sides. Square root of 8 can be reduced as, well, let's say 8 is 2 times 4. 4 is 2 multiplied by 2. Takes 2 copies to come out of square root. So you will have 2, and then 1 of the 2 stays inside the square root. So we have 2 square root of 2 on the right-hand side. On the left-hand side, square root of something square is the absolute value of itself. And the absolute value, you could go left or right, because absolute value is distance from 0. So if the distance is square root of 8, I could go up to the right to get a positive square root of 8, or I could go to the left and get negative square root of 8. Okay, so absolute value, you get 2 answers, because you could go left or right and still stay the same distance. The last thing to do is minus 7. So x is equal to negative 7 plus or minus 2 square root of 2. Now, what is really powerful for you to be able to see is to visualize the graphs of the scenario. On the left-hand side, this parabola is in vertex form. So if you visualize this graph, you would say, look, it's a parabola getting moved left 7, down 5. And it is vertically stretched, so it's a parabola looking like this. Okay. On the right-hand side, y equals 11 is a horizontal line. So if that is a horizontal line, it is going to cross the parabola in 2 places. So you can see now that there are 2 solutions. All right, so next, I want to go over the method of factoring. Okay, so factoring to solve. Well, there are 2 problems being posed here. On the left, we have things in common, and we call that factoring GCF, the greatest common factor. On the right, we have 3 terms, and that's a trinomial. So let's deal with the left-hand side first. When you have greatest common factor, in this case, greatest common factor is 2x. We're going to go ahead and factor out 2x, and we are left with x squared plus 4 inside. We now have 2 factors, 2x and x squared plus 4. So the zero product property says that either 2x is going to have to be 0 or x squared plus 4 will have to be 0. If 2x is 0, then x must be 0. If x squared plus 4 is 0, then x squared is equal to negative 4. So that we can square root both sides now. And x squared, square root of x squared, is going to give us an absolute value of x. Square root of negative 4 is 2i. absolute value, you can go left or right. So you will have a positive or a negative 2i as your x value. There are 3 solutions there. Okay, so most of the time here, we would say the maximum solutions is whatever the highest exponent is, in this case 3, right? So we'll try to account for 3 solutions, and you can see 1, 2, 3, and we're good. Now, checking your answers actually is the best way to make sure that your solutions are correct. So you can plug that in on your own and make sure they work, right? Then next question here on the right-hand side. Well, it's equal to 10. So we need to make that in standard form where it's equal to 0. Why does it need to equal to 0? Because we are going to factor and use what we call the 0 product property, not the 10 product property, right? So we need to make it equal to 0. And then we're going to factor the trinomial on the left-hand side. If you need help with factoring, watch the previous video on factoring. So now we have 2 factors. So either 3x minus 2 is 0 or x plus 5 is 0. If 3x minus 2 is 0, I got to add 2 divided by 3, so x is equal to 2/3. And if x plus 5 is 0, I subtract 5, and x is negative 5. Okay, now again, plug in your solutions to make sure they are correct. The next type of factoring is a special factoring method, and that is called the difference of 2 squares. Okay, so x to the 4th power minus 16. As we remember, a squared minus b squared will equal to a plus b times a minus b. So here, what square will give you x to the 4th? It's x squared. So a is x squared. What square will give you 16? 4. So b is 4. So I will have x squared minus 4x squared plus 4 equal to 0. I have 2 factors multiplied to each other to give you 0. So you would have to say that either x squared minus 4 is 0 or x squared plus 4 is 0. If x squared plus 4 is 0, we've seen this before. Square root both sides. I'll have absolute value of x is equal to 2i. Absolute value, I could go left or right. So x is either plus or minus 2i. If x squared minus 4 is 0, then x squared is equal to 4. Square root both sides. Absolute value of x is 2. So x is plus or minus 2. Again, x to the 4th power, I have 4 solutions, and things look good. Okay, so if something is not factorable, for example, 3x squared plus 6x minus 5 equal to 0. And make sure that it's not factorable because, factoring would be your most efficient method. All right? So if it's not factorable, you have 2 choices. This is the first choice, is to complete the square. We've learned how to complete the square before, so here it is. Add the 5 over, divide it by 3, okay? And then half of 2 is 1. 1 square is 1, so the missing number to make a perfect square is 1. So I'm going to go ahead and add 1 to both sides. So on the right-hand side, I have 8/3. On the left-hand side, I have a perfect square. And that becomes an onion problem. And how do we deal with onions? Peel off the layers, right? So to undo square, we will square root both sides. Square root of something square is the absolute value. So we have absolute value of x plus 1 is equal to 2 square root of 6 over 3. The absolute value could be negative or positive. So I have x plus 1 is plus or minus 2 square root of 6 over 3. And then subtract 1. That would be our solution. And you may say, wait a minute. How did square root of 8/3 become 2 square root of 6 over 3? We do what we call simplify and rationalize. Square root of 8 over square root of 3. Square root of 8, we know, is 2 square root of 2. We've seen that before, over square root of 3. In order to rationalize, we would multiply by 1. Rationalizing means to get an equivalent fraction, so multiply by 1, meaning multiply the top by square root of 3 and the denominator by square root of 3. In a sense, you are multiplying by 1. So now the denominator has square root of 3 squared, which is 3. On the numerator, 2 on the outside stays. Square root of 2 times square root of 3 is square root of 6. And that is how we got that answer. So completing the square, if it's not factorable, if the quadratic is not factorable. Okay, so we get it equal to 0 in standard form, and we realize it's not factorable. So we complete the square to solve. Now the other way, instead of completing the square, you could use the quadratic formula. What does that say? If you have ax squared plus bx plus c equal to 0, and it must be in this form, if that is the case, then x is going to equal to the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And that is the solution to all quadratic equations of the form ax squared plus bx plus c. So for our problem here, when you see 3x squared plus 6x equal to 5, you would say, oh, wait a minute, it's not in the standard form, so I gotta make it equal to 0. Then I have 3x squared plus 6x minus 5 equal to 0. In this case, we would say a is 3, b is 6, and c is negative 5. And we'll just plug them in. So we will have x equals the opposite of b. b is 6, so the opposite of b is negative 6. Plus or minus square root of b squared. Again, b is 6, so b squared must be 36. Minus 4 times a, which is 3, times c, which is negative 5. All divided by 2a, and a is 3. Then we need to go ahead and clean up the things inside the radical there. Negative times a negative is a positive. 4 times 3 is 12, times 5 is 60, plus 36 is 96, plus or minus 6, negative, all divided by 6. And that is what x is equaling to. Then we got to go and reduce square root of 96. So square root of 96, well, I see 3. So 3 multiplied by 32 will give me 96. 32 is 4 times 8, and 8 is 4 times 2. I see 2 copies. That comes out of the square root. I have a 2 and a 3 left. 2 times 3 is 6. So this becomes negative 6 plus or minus 4 square root of 6, all divided by 6. And we see now that negative 6, 4, 6. They all have a 2 in common. So we can say x is equal to negative, divide everything by 2, negative 3 plus or minus 2 square root of 6 all over 3. And we have seen this solution in the previous slide. Okay, that's the same solution. So when things are not factorable, you could either complete the square or you use the quadratic formula, whichever you choose. Now, sometimes you will see things that look like a quadratic. Okay, so stare at that. E to the 2x minus e to the x minus 6 equal to 0. It looks like a quadratic. Maybe it is. Can we turn it into one? And the answer is yes. How? U substitution. Let u be e to the x. If u is e to the x and we go and square both sides, e to the x to the second power, when you have an exponent raised to an exponent, we would multiply the exponents. So u squared is e to the 2x. So our equation becomes u squared minus u minus 6 equal to 0. And that is a quadratic. So we're going to try to factor, which we can in this case. U minus 3, u plus 2 is equal to 0. So u is 3 or u is negative 2. But we didn't start out with u, we started out with x. So we got to go and solve for x. U is equal to 3, so e to the x is 3. And to undo exponent, we would use log. Okay, how do you know that there's a solution there? Because exponential graph looks like this. That is e to the x. 3 is right here. So that will cross at 3. And there is a solution. And to undo exponential, we use log base e. So you would say x is equal to ln of 3. Okay? The other solution, u equals to negative 2. Well, that means e to the x is negative 2. Well, that is definitely not going to happen. Why? Because there is e to the x, and negative 2 is down here. E to the x will never go below 0. So this does not give you a solution. Therefore, you only have one solution here, and that is ln of 3. And that is it for solving quadratic and the like.